In this lesson video, we will be taking a look at day 1A.4, and our lesson is over segment and angle bisectors. To start this lesson off, we will have some definitions to write down and some pictures to go along with those. So in this video, you're going to need to pause the video to copy these things down. So I'm actually going to pause my recording and get these things all written in for you so you can see them all at once. And then after they've all been copied down, then I will go and explain what each one of these means. So again, pause the video if you need to copy these down. But these are our basic terms for this lesson. First, we're going to look at what it means to bisect. The word bisect in geometry means to split something into two congruent portions. You wouldn't consider it a bisector if it splits something into unequal portions. Those portions must be equal, therefore congruent. And so the idea of a segment bisector is any point, line, segment, or ray that bisects a segment. So I'm going to show you what that might look like. If I have some segment AB, and I put point M right there so that AM is congruent to MB, that is a segment bisector. But it might not just be a point, it might be another segment. Let's call it MX. MX would then also be a segment bisector. Or maybe I continue it on past M through another point, maybe Y, ray XY would be a segment bisector. Or even if it was just a line altogether, and I could call it line XY, or maybe even call it line L, that would be a segment bisector. But the key fact is that we have congruent portions of AB, which makes that a segment bisector. Now, when we specifically look at a point that is a segment bisector, or a point that bisects a segment, that is a midpoint. So again, in my diagram, if I have segment AB and point M that creates congruent segments AM and MB, then M is the midpoint. So if M is the midpoint, what that tells me is those are congruent segments, and this idea leads me to the fact that the length of AM is equal to the length of MB. Okay? So if we have congruent segments, then lengths are equal, and we're going to use that in some problem solving today. And then finally, we have one more definition here, and that is an angle bisector. And as we look at what an angle bisector is, it's any line, segment, or ray that bisects an angle. So let's say I started off with this angle. We'll call it angle WVR. And in that angle, if I have some point in the interior that creates ray V, we'll call it X, and if angle WVX is congruent to angle XVR, then ray VX is an angle bisector. And in this situation, we realize that the angles created here, WVX and XVR, oops, forgot the angle symbol, angle XVR, are congruent angles, which means their measures are equal. Okay? So let's go ahead and apply these to some problems. We need to sketch each scenario and label the picture, then find the specified information. So I'm going to give you the worded example here, and then we're going to sketch that picture and fill in what they tell me and find what's missing. So we're told to make a sketch of segment AB that bisects segment CD. So segment CD is the one being bisected. So we're going to start with that one. CD. D, and AB bisects that segment at X. So X has to be exactly in the middle of CD. So AB can be any form here, A, B. But the main idea is that X is the midpoint then of CD. X is exactly in the middle because that's where the other segment bisects segment CD. So then they tell me to find the length of CD, that's our entire thing, and dx, so that would just be half, if the length of CX is 12.3. Well, since X is the midpoint because of AB being a segment bisector, that means that CD has to, I'm sorry, I wrote the wrong thing. Let me fix that. Sorry, CX has to equal XD. The big idea with midpoints and bisectors is part has to equal part. Last lesson we talked about the phrase part plus part equals whole, but with a midpoint or a segment bisector, part actually equals part. And not only does part equal part, that means if the parts are equal, and I double the parts, so 2 times one of the part lengths, you get the entire whole length. So this is kind of a big idea for this lesson. Only when we have midpoints or segment bisectors or even angle bisectors will this work. So let's go back to our example. In this example, CX equals XD. So if I'm supposed to find XD, dx is the same thing as xd, by the way. All right, just changing the order of those letters does not change the length. They both equal 12.3. So that's one of my answers. But they also asked for the entire length from C to D. Well, the whole thing is just 2 times 12.3. Or think of it as 12.3 plus 12.3. That will always be the same as 2 times 12.3. Which gives us a total of 24.6. Okay? So what we're going to do now, we're going to look at number 2. I'm actually going to have you try this one on your own. I'm going to help you set up the picture, and then you're going to want to pause the video to try it on your own, and then you can click play to check your answer. So let's get started. If M is the midpoint of segment AB, that tells me what drawing to sketch. So I'm going to draw segment AB and M in the exact middle. It's not just between them, it is in the exact middle. So M is the midpoint. That means AM is congruent to MB. Make sure you're marking the picture as you go. If you don't do this step, it's very hard to come up with an equation. All right? It says to find the value of X if AM, this portion, is 13x minus 24, and actually you can write it like that, or you can just write it directly in here, 13x minus 24, and BM, which is the other side of my segment, is 10x plus 36. What is the length of AB? So what I want you to do is pause the video, write an equation that relates these two parts. Remember this. Write an equation, solve for x, and then plug back in to find the entire length. Okay? If you need any more time, pause the video. Otherwise, this. When you set up and solve your equation, you're using part equals part again. That means I can set these two values, and when we solve that equation for x, we should get x equals 20. If you didn't get x equals 20, go back and check your equation that you solved. Either way, if x is 20, then when we plug it back in to find the length of AB, remember that the whole thing, AB, is really just 2 times any individual part of that because the parts are equal. So I chose to plug in for AM, and since AM is 13x minus 24, I made that 13 times 20 minus 24, and then that final answer there gets doubled, and I get 472. So the length of AB is 472. So let's try. So as we look at number 3, we're told that m is the midpoint of AB. And they want you to find the value of x if AM equals 15x minus 24 and AB equals 10x plus 36. But then they also ask what is the length of BM. So we're going to draw this again. M is the midpoint of AB. So your segment has endpoints of A and B. M is in the middle. These are congruent. Find the value of x if AM is 15x minus 24 and AB, the entire thing. Notice this is the whole amount. This tells you what endpoints to use. That's our whole segment is 10x plus 36. So this is a little bit different. This time, we're not saying part equals part because I don't know the other part. I know one part and I know the whole amount. So I'm not going to use part equals part. I'm going to use 2 times that part value equals the whole value. So in this case, this is your part, and this is the whole. So if I do 2 times part equals whole, that becomes 2 times 15x minus 24 equals the whole amount, 10x plus 36. Okay? So if I start to solve this, the first thing you have to do is distribute this 2 to each of those, giving us 30x minus 24 equals 10x plus 36. And so we would subtract 10x from both sides, which gives you 20x on the left. And then I'm also going to add 24 in the same step because it cancels that one. So I get 20x on the left equals 60 on the right. Divide by that 20, and we get x. So if x equals 3, we're going to evaluate for the length of BM. Well, that is this unknown value. But remember, the parts are equal. M is the midpoint. So BM, or MB, has to be equal to AM. So I'm just going to plug in my 3 for x into the value for AM, 15x minus 24. So I make it 15 times 3 minus 24. 15 times 3 first is 45. And then I subtract 24. I get 21. So the length of segment BM and AM. Moving on to number 4. Excuse that bell. Moving on to number 4. We've got ray XY bisecting angle AXB. Now before I even read the rest, I'm going to draw that. This first thing tells you what picture to use. So I'm going to draw angle AXB first. I'm going to take up enough space to where I can clearly work with the problem. So if it's angle AXB, the vertex of your angle has to be x, and either of these other 2 points can be A or B. So I'm just going to go top to bottom. So that's angle AXB. Now I want to draw ray XY as an angle bisector. That means I want this ray to cut that angle into 2 equal halves. Again, just try your best to draw that to where these look like they're the same, and I want to mark them as congruent angles. So this is ray XY. This is going to help me figure out the parts. This is one part angle, this is another part angle, and the entire angle of them glued together like that is the whole amount. Well, now I'm going to fill in what I know from the problem. We are given that the measure of angle AXY, that's one of the parts, is 43 degrees. Now they just say find the measure of angle AXB. AXB, that was our whole thing. Well, in this case, if one part is 43 degrees, The other part is also 43 degrees because this is an angle bisector. It splits angle AXB into two equal portions, two congruent portions. So the whole thing is either 43 plus 43 or 2 times 43. Either way, you get the answer 86 degrees. Since we are working with angles, we always give our measures in degrees, using your degree symbol, small circle there. All right, we are actually going to skip example 5 for a couple reasons. One, I'm trying to keep the video shorter. Two, the numbers don't work out very well in that example. So we're going to jump right over here to example 6 to finish the video. So again, we're told ray XY bisects angle AXB. So we're going to draw that ourselves. It doesn't have to be perfectly straight lines, just try your best. So there's angle AXB. That is our whole amount. And so XY is our angle bisector, which creates congruent angles. We are given that the measure of angle BXY is the expression x plus 42. So BXY is a part. So I'm going to write, keep wanting to write that 4 first, and that's not true. I want to write x plus 42. X plus 42. And the measure of AXY is 5x minus 4. So this time I'm given the two parts again. We kind of did something like this with our segments. But to find the measure of angle AXB, the entire thing, I need to say part equals part. And so I set up this equation. That's going to help me find x. And then after that, I can plug in and find the total angle measure of the whole angle AXB. So if I subtract x from both sides, and that gives me 4x minus 4 equals 42. Then I add 4 to both sides. I get 4x equals 46. Sorry about that, jumped the screen on you. So like I said, we get 4x equals 46. And to finish this, we would just divide by 4. Now, it may look like something is wrong. There's nothing wrong with this. We do get a decimal value, but it's not a strange decimal. 46 divided by 4 is 11.5, or 11.5. We can still use that value to find an angle measure. We are told to find the measure of angle AXB. AXB is the entire angle measure. Okay, so what it means is I'm going to take this 11.5 and plug it in for x, really just in one of these parts. I'll choose this one because it's a little easier. All I have to do is add 42 to that, and I get 53.5 degrees. But because these are congruent angles from the word bisect, we know that this is also 53.5 degrees. So whenever I combine those for my total angle, AXB, if I do 2 times 53.5, I should get 107 degrees. So that finishes our notes on segment bisectors and angle bisectors. You're going to get a chance to practice this in the homework 1A.4 assignment